Okay, hello everyone. All right, so I want to discuss question 6D of the 2022-2023 SP025 paper. All right, so this question is on physical optics. So let me just write down there, physical optics. Okay, let's read the question. A 632 nanometer wavelength light, so that's my wavelength, passes through a double slit. It's very important, at normal incident. So here I have, let's just draw it out. I have double slits. Okay, then here's my screen, and at the middle of it should be a bright fringe. Okay, so that's the central maximum. Let's just use red for central maximum. And then I have my first one, and then my second one, my first one, and then my second one. Okay, let me just rescale that. Okay, so interference pattern is formed on the screen 1.4 meters away. So that's my distance from the slit to the screen. So here's my screen, and here's my, that's my slit, and that's my screen. This is my D. The distance between second order bright fringes is 23 millimeters. Okay, so this is my central maximum, first order, second order, first order, second order. So the distance between these two is going to be 23 millimeters. Okay, so that's going to be my distance between second order bright fringes. Calculate the slit separation. Okay, so I'm looking for the slit separation. Now, for double slit, right? And then bright fringes of double slit, I will have ym equals to m lambda d over d. Okay, what does this ym represent? Let me just get rid of that. Just change colors. I want to change colors just so that makes it a bit easier to see. So I have ym. So what is this ym? Well, ym is going to be, so for example, if I go to the second order, this is going to be y2. Okay, notice that this 23 millimeters is actually twice y2. So that means ym is simply 23 millimeters divided by 2. Okay, and that gives us actually 11.5 millimeters as my ym. Specifically, this m should be m2. All right, and this becomes 2. Okay, so now we can substitute the values. I have y2 equals to 11.5 times 10 power of negative 3 equals to 2 times 632 times 10 power of negative 9, because we have nano, right? Nanoscale, nanometers. Then my distance is simply 1.4 meters away, and then I divide it by the slit separation. Okay, now I can exchange the position, right, for those two, and what I'm left with is d equals to 2 times 632 times 10 power of negative 9 times 1.4 over 11.5 times 10 power of negative 3, and that gives me a slit separation of 1.54 times 10 power of negative 4 meters, and that, my friends, is the slit separation. So the slit separation for these conditions to be fulfilled will be 1.54 times 10 power of negative 4. Okay, all right, thank you very much.